Okay, so let's keep going with this idea of inverses, trying to find angles instead of finding values. So wouldn't hurt to talk about where these guys are defined again. So everything's going to be defined in quadrant 1. Okay, that's not a problem. So an inverse cosine, an inverse sine, and an inverse tangent. Okay, cosine's positive in quadrant 4, so we're going to grab an inverse cosine over here. So we get one positive, we get one negative. Sine's positive in quadrant 2, so we're going to grab one down here in quadrant 4. The only one you got to remember is the tangent. So that's because the graph of a tangent goes from negative pi over 2 up through pi over 2. When we looked at these guys, so that's the domain we restricted it. So that's why tangents happen in quadrant 4. Okay, so let's start putting some stuff together, some tougher types of problems. Okay, exact value of a cosecant of an inverse cosine of 1/4. So the book does a nice job of typing all this stuff up. So I leave those on there, but if it helps you, great. If not, don't worry about it too much. Okay, start on the inside here. We're doing an inverse, so we're basically trying to find an angle. Okay, so we're trying to find some angle where the cosine is 1/4. We don't care about what this guy is right now. Okay, it's just going to confuse us. So we go back to what we know. We know cosines happen, or inverse cosines happen in 1 and 2. If it's positive, it's definitely going to happen in quadrant 1. So we can go draw a triangle now in quadrant 1, throw in a cosine of 1/4. Okay, it doesn't matter that we don't know what that value actually is. So if we do that, we determine it's in quadrant 1. We'll make a bigger picture of it here. Okay, cosine has got to be 1/4. Here's the work here to show you how to get the second leg. Just make sure you don't put that leg as your hypotenuse. Okay. Now again, we don't know what this theta is, but it really doesn't matter to us. Okay. Doesn't matter that we don't know the exact value. So now we go back to the original problem. It wanted a cosecant of an inverse cosine of 1/4. So we've basically replaced this entire inside with a big theta. Again, we don't know what it is. It doesn't matter. We have a triangle for it. So now the problem is just cosecant of theta off of this triangle. Okay. I'm not great with cosecants, so I always go do sines first, and then I'll just flip it. So the sine of this guy is square root of 15/4. So that means my cosecant then is 4/15. Make sure you rationalize, and it'll take you down to this guy and this guy right here. So the trick is, when you see these problems, start on the inside, replace it with whatever you need to, whether it's a value, whether it's an angle. So literally take this piece here, say that's a theta. Okay, set up your triangle, grab whatever else you need to off of there. Okay, and your book's got a couple examples if you'd like to look at those before we practice them tomorrow as well. Okay, there's one thing. We're going to look at a lot of different problems like that. Next thing is we get these three other inverses. Okay, cosecant, secant, and cotangent. Now, we talked about the whole idea of doing a one-to-one function, flipping domain and range. Domain of your original becomes range of your inverse and vice versa, all that. So if we look at a cosecant here, okay, it's the thing in green. We got to go through that whole process again. We got to make this guy a one-to-one function. Well, for a sine, we took this little piece right here. Okay, we said inverse sines happen quadrant 1 and quadrant 4, so that's the negative pi over 2 up through positive pi over 2. So we're going to do the same thing to grab the inverse of that guy, or the reciprocal function, sorry. So we're going to grab this piece, and we're going to grab this piece, okay? Now domain and range are going to do some different things for these guys, okay? So for the old function here, your domain was anything from negative pi over 2 up through positive pi over 2. Okay, we're ignoring the fact that the asymptote isn't going to have a value at 0, but we can take care of that later. The range of this guy, well, it's basically everything except this gap here in the middle. So the lowest value this thing will ever get is from this negative 1 coming all the way down. So we're going negative infinity up through a negative 1. Okay. The highest thing this guy will ever reach, starting at a 1, and this guy takes off to positive infinity. So then we also have this guy from 1 to positive infinity. So when we go do the new function now, our domain and range are going to flip. So when this domain and range flips, when we go do the inverse here, okay, this domain becomes your y values, this range becomes your x values. Now I gave you guys that little handout with the first 3 yesterday, so on the back you can add these next 3 in, or put them on your notebook paper, or transfer them over later. So if we look at this guy right here now, so an inverse cosecant means x equals cosecant of y. Okay, we talked about this used to be the domain, it's now the range, because y values, we're ignoring the asymptote. Okay, they take care of it right there. It can't be a 0. And they say it a little bit differently. So they say absolute value of x is greater than 1, meaning we had that negative 1 to negative infinity. So if you had, like, let's say negative 3 down here, it still works. Okay. Yesterday I gave you guys that problem where we said you're trying to do inverse sine of 2. Well, the sine can't be a 2, because according to the graph, the biggest thing a sine can be is a value of 1. However, a cosecant can be a 2. Cosecant will never be anything from negative 1 to positive 1. Okay, we do the same thing with the secant here. We have to restrict this graph so it becomes a 1-to-1 function. Well, we restricted the cosine in this little region right here, so it passed the horizontal line test. So that means we're going to take this piece here, and we're going to take this piece here. Okay, so for the old function, or the original, however you want to think about it, our domain used to be 0 through pi, because we said inverse cosines were defined in 1 and 2. The range for this guy, well, again, we look at this thing here. They'll never be anywhere in this middle. Okay, so it's going to go from negative infinity to negative 1, and then also 1 to positive infinity as well. Here's the little bit with secants. Same idea, except just like we talked about on Monday, here's your new range. Okay, because secant or cosines happen in different places that sines do. And again, they use that absolute value of 1 notation, and this takes care of the asymptote. Okay, so if you wanted to add that to your sheet. Okay, part 2, we'll look at cotangent.